Shania is quiet. So for example, if we begin with the if we begin with the what do we get from the forest? Doris,
Yes,
what
teacher.
what what can we get from the forest?
Wood.
Food.
No wood.
Wood. Okay, wood. Shania, what can we get from the forest? Shania is quiet. Okay, apart from wood, what else can we get from the forest? So if we get if we get wood from the forest, now that means that the wood and the forest are related, isn't it so?
Yes, teacher.
Yes. So we would say now that the forest gives us wood, and then the relation there would be the relation between the forest, the relation between the forest and the wood is that the relation there is gives. So the forest gives us wood. Then Doris has said it gives us local medicine, or we get local medicine from the forest. So the
Yes.
forest gives us local
Medicine.
medicine. Yes. So still there we have the word gives. So yes, we get local medicine. Okay, the forest gives us medicine. How about if we begin with medicine and then the wood? How would our statements be? Shania, you can speak. If you begin with medicine, how will your statement be? So we are saying forest gives us medicine. How about if we begin with medicine?
Medicine is gotten from the forest.
Okay, it's gotten from the forest. So now got from the forest would now be the relation. Okay. So as we are saying, the forest gives us very many things. So we get wood, we get medicine.
Get, we get leaves for green manure.
Yes, we get leaves for green manure.
We get timber for building, which is like wood.
We get timber for building.
Get charcoal fuel.
We get charcoal, we get fuel. So they are very what? They are very
Very,
many. So we are saying we were saying we get very many things from the forest, and therefore the forest is connected to all those products. Okay. So
Yes.
here we are saying a relation is a connection between members within one set or more than one set. Okay. So like the one we have just discussed, we are having a forest giving us medicine, firewood, manure, poles for construction, medicine, and etc. So it is one giving us many. Okay. And later when we come to types of relations, we shall have a one to many. That it is one, but it is giving us many. It is related to many what? Many products. Then here we are saying may also be called a defining condition. So it is a condition like we get firewood from the forest. Okay. So it is a condition that we have to get firewood from
The forest.
the forest. Okay. Can you read these other three? Older than, bigger than, less than, and younger than.
Older than. Ismail is older than Arusha. Bigger than.
Is older
Barbara
than.
is
Mm,
Barbara is bigger than me.
yes.
Less than. 2 is less than 9. Younger
Yes.
than. Helen is younger than Peace.
Okay. So what is the relation in the first one? In the first one where we have Ismail is older than Arusha.
Older than.
Older than is the relation. Yes, Barbara is bigger than me. So what
Is
would be the relation?
bigger than.
Bigger than. Yes, then 2 is less than 9. What would be the relation?
Less than.
Yes, Helen is younger than Peace. What would be the relation there?
Younger than.
Younger than. Okay. Can you form like other two which are not here? Can you form your own relations using either older, bigger, less than, or younger than?
Mm. Sean is younger than Marvin.
Yes.
Solomon is taller than Helen.
Okay. Okay. Thank you. So had you tried to open this mathematics course?
No, I had not yet accessed it.
Sure.
Yes.
Okay. So when you access it, you'll come and watch this video, but I think we haven't even reached there. So let us continue with forming our relationships. So here we have Peter and Jessica. And here we are saying Peter is a brother to Jessica. So what is the relation there?
A brother too.
A brother to. Okay, then we go to number 18 and number 9. So I'm saying number 18 is more than 9. What is the relation?
More than.
More than. Okay. Then these relations can be represented on a papergram, and that papergram is a diagram representing relation with members of a single set. So we have a set, then we represent those on a parallelogram, but we are going to also look at it later.
Yes.
Then we also go to a mapping. Okay. Have you ever stood in a mirror and observed yourself, your image?
Yes.
Yes. So this one here is still like the same. So we have an object, okay, which we call the domain, and then we have an image that we call the range. Okay, so we are given values and then a function, and then we substitute and get what? The image, like the way you can see yourself in a what? In a
In
mirror.
a mirror.
So yes, so these videos you'll watch them later, okay,
Yes.
when you access the course. Okay, so we are saying in our example we have x and is being mapped to what?
To
To
X.
x. So in other words, we are increasing its size. We are making it bigger. If it was a smaller object, now if the image will be what? Will be bigger.
Mm.
So this first one here where we have x, we call this one the domain, and then this one where we have this second one, we call it a range. Okay. Yes. Now these arrows show that from 0 was taken to what? To 0. So the image of 0 is 0. Okay, so we substitute in the 2x. So if x is 0, then here we shall have 2 times what?
2 times 0.
Times 0, and it gives us a what?
0.
A 0. Yes, then we have 1. So we shall get also 1 times 2, or okay, 2 times 1, and it will give us
2.
a 2. Then we have 2 times 2, it will give us a what?
A 4.
A 4. Then we shall have 2 times 3, it will give us what?
6.
6. And then 4 times 2 will give us
8.
8. Okay. So this is an example of what? Of how we can represent how we can be able to represent our relation on a mapping. So we call this diagram what? A mapping.
Yeah.
Okay.
Yes.
Maybe let me first stop sharing this, then I share again. A blank. So here we are going to have, so if we call this one a forest, okay,
Yeah.
and then this side we had the very many things we are getting from this. So we
Excuse me,
had
teacher.
wood.
Excuse me, teacher.
Yes,
My connection is
yes,
not
please.
fine. My connection is not fine. I can't hear you and I can't see anything.
Sure. What
Yeah,
could be wrong? So that is why the net you had disconnected.
yeah.
Okay. So you can't hear and you can't see anything.
Yeah.
How about if you refresh? Okay, let us wait for her briefly.
Yes.
Okay, meanwhile, let me be drawing this. When she comes, we shall explain.
Teacher, it's better. Thank you.
You're welcome. Okay, so we had wood, we had medicine, we had boards for construction, then we had manure. Okay. So this one we can better represent it when we draw something like this, our mapping. Okay. And then we put here our forest. Okay. So this will be the forest, and we say we get wood, we get medicine, we get poles, and we get organic manure. Okay. Then here we would represent this with the arrows. This is going this way, still giving us that. So this one here we call it what? An arrow diagram, and the everything, or we can call it a mapping. So this is an arrow diagram. Okay. So now this better shows us that wood, the forest gives us wood, the forest gives us medicine, the forest gives us poles for construction, and the forest gives us
Excuse me, teacher.
organic manure.
Excuse me, teacher.
Yes? Yes,
I have a
please.
question.
Yes.
What depends on where the arrows place?
Yes. The arrows. So the forest here the relationship would be the forest gives. Okay. So the relation is the one that determines where the arrows,
Yes.
where the arrows go.
Thanks.
Okay.
Yeah.
So if the relation was got from, okay, then we would have our arrow diagram. So this would be forest, then W, then M, then P, and the OM. So now here the arrows would do what? Would change, because we are saying is got from. Okay. So this is now the relation. So the arrows would now do what? From, so from the forest. But the other one, the forest would give. Okay. So have we mastered how these arrows should move?
Yes.
Okay. So can I rub this?
Yeah.
Yeah.
Okay. Then a relation like younger than. Okay, so the arrow would move in the other direction. My internet had disconnected me. So on how we can represent the relation James is younger Amos. Okay. So we shall have our names James and Pete and Musa. Then Musa. So where is our arrow going to be facing with the relation younger than? Where is our arrow going to be facing? Towards Musa. Yes, Doris, where is our arrow going to be facing?
It's going to face towards Musa.
Musa. And the relation is going to be younger
Than.
than. Okay. Let us do more like the ones we had said. 2 is less than 9. So we shall have how is our relation going to be? To the left. Okay. So we are having 2 facing 9, but the 2 is
less
less than. Okay. Then when we have 9 and 2, what will the relation be?
9 is
9 is
more
greater
than 2.
than 2.
Is more than, so it can be 1
9 is greater
more
than
than 2, greater than. Okay. Any question on
Excuse me, teacher. Can they ever ask, okay, like they bring a sentence, maybe like 2 is equal to something, and then they want you to represent it?
Okay. Let's now go back to so we have seen how we represent individual relation on an arrow diagram. So now go ahead with the many, so like many to many. So we are having values of x,
Teacher, the
which I
screen
said
is not clear.
the screen is not clear. Maybe it's network there. How about for Shania? Is your screen clear?
Yes.
Doris, maybe a network again.
Okay, let me try.
Okay. So we are saying if from the first where the arrow originates from, we call that one a domain, okay? And
Yes.
where the arrow goes, we call that a range.
The range.
Okay.
Yes.
So we have this diagram here which shows the domain. So A is going to a certain value, Roman 1. B goes to Roman 2. C goes to
C to
Roman
Roman
3.
3.
Okay.
Yes.
And D to Roman 4.
4. And D to Roman 4. So that means
Yes.
A, B, C, D are in the range, are in the domain, and Roman 1, 2, 3, 4 are in
The range.
The range.
Are in the range. So after we are saying a mapping diagram consists of two parallel columns. The first column represents the domain of a function, and yes, and the other column for its range. Okay.
Yes.
Then we are having that lines or arrows are drawn from the domain to the range. So Yes, as I have just said, the arrows are going to move from D to Roman 4, C to Roman 3, so it is from the domain to
the
the
range.
range, as we have seen it in this upper diagram.
Yes.
And then Doris, we said we are going to watch these videos later. Okay. We are also going ahead to say a function represented by mapping in that above is so in most cases we find that some numbers in the range may have more than some numbers range may have more numbers that they come from the domain, or we I think, Doris, you can see that you are not the only one being affected by the network.
Yes, teacher.
So I was saying this diagram here where we have domain ABC, then we have range from 1 up to 3. Okay. So are we
Yes.
seeing numbers that are going to 1, numbers from the domain that are going to 1 number in the range?
Yes.
Yes.
And what are those numbers?
B, C,
All letters. Okay.
and A.
C and A, because A moves to Roman 2 and C also moves to Roman 2.
Two.
Okay?
Yeah.
Yes. So what we saw, this one here, this first one is a type of mapping that has a 1-to-1. Okay? It's a 1-to-1 mapping. Yes, like what we are seeing here, this expression says a function represented by the mapping above
in
in which
which
mhm.
in which each
Read, continue.
element
Mm.
of the range is paired with exactly one element of the domain is called one-to-one mapping.
Is called a 1-to-1 mapping.
Yes.
Has only one element in the range, so is paired to one element in the range. So that one is called a 1-to-1 mapping.
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 Okay.
Yes, teacher.
Then we come to this second one here that we are from explaining. Okay.
Yes.
So who can read? Who are the one that had not read the previous?
Shania.
Shania.
In the mapping, the second element of the range associates with more than one element in the domain. If the elements in range that have mapped more than one element in the domain is called many to one mapping.
So we have a many to one mapping. So we have in the range many or more than one elements being mapped onto. Okay, so we are saying the range associates with more than one element in the what, in the domain. So like what we are seeing here, that A is mapped onto A2 to Roman 2, and C is mapped onto Roman 2. So A and the
A and C.
A and C.
so A and C are mapping, all of them are mapping onto Roman 2. Okay,
Roman 3.
so that means yes, that two of them, two in the domain, are having the same what? The same image. And we are calling that a many to
One mapping.
One.
a many to one mapping. Yes, then we go to yes, we got this other one. So what do we observe from this diagram now? This one here, domain to range.
A has two
A
different
and
images in the range.
A has two different images in the range.
yes.
Okay, what's so we're saying in this mapping, the first element in the domain have mapped with more than one element in the what? In the
In the
range.
range.
Okay, who can read?
Doris.
Doris.
In this mapping, the first element is the domain have mapped with more than one element in the range.
The mapping word.
In this mapping, the first element in the domain have mapped with more than one element in the range.
Continue.
If one element in the domain mapped with more than one element in the range, the mapping is called one-to-many relation. One-to-many relations are not functions.
Functions. Yes. One-to-many relations are not functions.
Functions.
Okay, so we are saying A has 2, so it maps into 2. So this one we call it a one-to-many, and they don't form a function because a single object has two images. Okay,
Yes.
so a single image has two objects, so that is why we are saying it does not become a function. So a one-to-many relations are not functions. Okay.
Yes.
Yes.
So we can look at an example. So we are saying draw a mapping diagram for the function f of x is equal to 2x squared plus 3 in the set of real numbers. Okay.
Yes.
So here they have not given us the values of x. So we are saying here we are going, yes. So this one, let x
The
to be
domain of the function is all real numbers. Let
real
x
numbers.
equals -1, 0, 1, 2, 3.
Yes. So when we get, so it is 2x squared plus 3. So can we do it on the other sheet I was using? Let us first stop sharing here. So we have the function is equal to 2x squared plus 3. And then our x values are negative 1, 0, 1, 2, and 3. Okay? So we are now going to begin substituting. F of negative 1 is going to give us 2 times negative 1 squared plus 3. What is negative 1 squared?
1.
1 times 2,
2.
then plus 3 will give us
8.
f of 0 would be 2 times 0 squared plus 3. And what would that one give us?
0 plus 3, giving us 3.
So we have 1 squared will be 1 times 2 times 2 is how much? And then we also find f of 2, which would be 2 times 2 squared plus 3. What is 2 times 2 or 2 squared?
4.
4. Then 4 times 2?
8.
8 plus 3?
11.
11. And then also find f of 3.
3.
This will give us 2 into 3 to power 2 plus 3. 3 times 3 squared is
9.
9. So we shall have, Doris, what is 9 times 2?
16.
Not 19.
19 times 2
9
is
times,
9 times 2
no,
is 16.
about 8 times 2?
16.
So 9 times 2 is 18. Okay?
Yeah.
Yeah.
So we get 18 plus 3, it will give us 20, 21. Okay?
Yes.
So now we have got all the values of fx, so we can draw our what? Our mapping. So we had -1,
0,
0, 1,
1,
2, and
2,
3.
and 3.
Let me see.
5.
Sure. So we have 5.
Yeah, 5.
I think.
3.
So we can begin with 3. Then 5. Then
11.
11.
mm,
21.
21. Okay.
Yes.
So -1 gave us what? A 5.
5.
Okay, which is
Yeah.
here. So -1 will go to 5. Okay.
Yeah.
0 gave us 3. One also gave us 5, and then 2 gave us 11, and 3 gave us 20.
1.
Then here we can say x. The relation here is
2x squared plus
2
3.
plus 3. Okay, so this is the range, and this is the domain. Okay.
Yes.
Any questions?
No.
No.
Okay. So I'm going to prepare some work and send it to you.
Yes, teacher.
And then you'll be able to do it. Okay.
Yes.
Okay, thank you. Bye for today.
Bye.
Bye, teacher.
Nice day.